a little note. Up until now, we were talking about the vector space, and our dimensions were single words. Now, you could try to go beyond single words as dimensions. So let's look at an example of how you could do that. And the neat thing about the vector space model is you don't actually need to change much to do that. So here's our little story, and if we used single words and frequencies as the representation, this would be the vector representing it, right? So the word stars occurs 4 times in our space and so on. That's the representation of a document. It's a nice summary if you look at it, but it could be better, right? Now, what happens if we take phrases? And the simplest possible definition of phrase is you just take a bigram. You take a pair of adjacent words in the document. So, how single is a pair, single stars is a pair, stars lost is a pair. So, if you take the bigrams and start counting them, these are the sort of bigrams that you would get. You'd get a lot more of them, of course, but these are the ones that come out at the top. So all stars, stars are, why some. Now, how do you use it in a vector space model? You use it just like it is shown here. You take adjacent pair of terms, and you use that as a token. Right? So instead of individual words, you just take a pair and use the pair as if it were a single word. And then everything else in the model stays the same. It's just what you've done is you've blown up your vocabulary. Your vocabulary used to be in the millions, and now it's going to be a million square because you're looking at pairs. The rest of the model stays the same. And of course, you could generalize it in lots of ways. You don't have to take adjacent words. You could slide a k-word window and look for any pair of words between that. That will really blow up the size of every document. But of course, you could restrict it in lots of ways. And if you're coming from an NLP background, there's lots of room to play here. So you could take noun phrases, verb phrases, any kind of dependency chains, had modifier pairs. So here's an example of the noun phrases that would come out of that. Of that representation. It looks like a very good representation. You look at it with human eyes, and it seems to make sense, right? That is a lot more informative than that to the human eye. Unfortunately, that's about it. It's a lot more informative to the human eye. Getting it to work better than single words is exceptionally difficult. In some domains, you can do it, but it's hard, and you really have to work hard on selecting the right weighting. So it's a very attractive idea, but it's not very easy to get this to work.
How do you treat the query words? Like, do you treat them as a single, or do you cluster them as well?
So the question is, how do you treat the query words? So this is one place where it raises its ugly head, right? The normal web queries. They are not really phrases. People put words in rather arbitrary order on the web, so you can't really do it. It's a little bit more natural if you have narrative queries where somebody is typing a paragraph about what they want to find. There are applications. Or if you're using a document as a query, or measuring document to document similarity, because then you have the same well-formed text on both sides. For normal keyword queries, you wouldn't do that.
But the IDF will change as well.
The IDF, of course, will change.
The same idea, and will change again.
It's not the IDF that will kill you. What will kill you is the fact that the words in the queries will not occur in the same pairings as they occur in the documents. That's what makes this infeasible. Question?
Could you combine the two? Just take the words and the pairs?
Very good idea. So could you combine the two? Absolutely.